Good day. Thank you for joining me today. Um, we will be discussing about animal physiology today, about gases and some of the breathing mechanism of few animals. I am your speaker, Azizan bin Effendi with metric ID BS17110580. Let's go for the introduction. There are an abundance of non-organic and organic resides on Earth, such as air, iron, food, and others. And and unconsciously we are interacting with the surrounding. These non-organic and organic have their own unique properties and elements, such as oxygen gas, which was identified with two atoms of oxygen. So, what is the physiology of an oxygen? So, basically, oxygen is a gas. It is important to all living things and essential role for chemical reaction. Living organisms need oxygen for respiration, such as terrestrial creatures, aquatic creatures. Without oxygen, on Earth it is impossible for an organism to continue living. While the physiology of a carbon dioxide is the same as the oxygen. It is also a gas. It is a product from our body and disposed of through exhaling. And it also from the carcass decomposition, the produced, and if the percentage of a carbon dioxide is greater than oxygen, it will cause global warming and it will be fatal to all of the surrounding beings on Earth. And it could be an indicator for health warning if the amount is imbalanced in our body. So we will jump to the breeding mechanism of a few organisms. Some of the organisms have open respiratory um, breathing mechanism, and some of the organism have closed breathing mechanism. So as you can see here, this is the grasshopper, and below the thorax it will be the abdomen, and the abdomen also consists of spiracles. So these spiracles plays a major role to the insect. So the oxygen will go in through the spiracle and reaches the trachea. Looks like a branch leg, and this little branch leg will be called tracheal. And this is where the oxygen will diffuses in through the system of the insect body. And after the oxygen has been used up from the insect's body, it will produce carbon dioxide, and then the carbon dioxide will diffuses out from the tracheal and spiracle itself. Next will be the breathing mechanism of a fish. So you can see that this body of the fish over here on the slide, the water will flow inside the mouth, and it will go through the gill filaments over here, and then after the water go through the gills, this one, the capillaries, the water will go through the capillaries, not through, but this one will go, yes, it will go through the capillaries, and also it will diffuses in the oxygen. If you can see here, the percentage over here is the concentration of the oxygen here, and this system is called countercurrent of diffusion in the capillaries of the fish. And then the carbon dioxide will counterly diffuses out from the inside the water, and it will just give and take over here. This is how the oxygen will be transported in the capillaries of the fish body. Next one will be the breathing mechanism of an amphibians. So amphibians, they have two type of different methods of breathing. You can see that here over here, the frog will breathe through their via lungs and also skin as well. So in aquatic stage, they have breathe through gills. As adult, they breathe through lungs, skin, or both. Some have a primitive lung structure and rely on diffusion of oxygen through skin, so they must always stay moist in order to breathe through their skin. And some have more efficient lungs and don't rely on breathing through their skin. Next one. So the next one will be the breathing mechanism of mammals. So basically, all mammals does this. So breathing, when we breathe in, our chest will be just go expand, and our ribs will also just, the cavity will just increase, and our diaphragm will be just contract. It goes flat, not entirely flat, but just flatten a bit. So, and next, when we breathe out, our chest will also contract. It will do the contract. Our ribs will also just go downward after expand. And then the lungs will also uh, the volume will also decrease as well, and our diaphragm will just relax. So that's the end of my presentation. Thank you for your attention for today.